Hi, my name is John Joseph, and this is the fourth part in my tutorial series on using my procedural text generation tool, ProcGenie. In this video, we'll be talking about moving between graphs, so moving from one graph to another graph. Up until now, we've talked about moving within a single graph. We've talked about defining a start symbol on a graph, which is the entry point for the graph. We've talked about directional rules like east, northwest, southwest that define where the walker or generator can move next. We've talked about how a cell is an anonymous non-terminal or a symbol that can be expanded into multiple different components. We've talked about how components are defined by entering text into the cell. You can define a single component by just entering text into the cell, or you can separate out and define multiple components by using the pipe symbol or the OR symbol to define multiple components. We've talked about establishing probability factors on a component by placing a number within brackets, and that the walker, when it hits a cell, that it'll move or choose between any of the components based on the probability factors. But now we're moving beyond that. We're going to talk about how to move outside of this single graph to another graph. To create another graph, you'll see graph name, graph type up at the top of the screen with a new and delete button. So let's just create another graph called other, and we'll keep it as graph type default. Now if we click on the default type here on the left side of the screen, we see new grid and other. So new grid, that's the first grid we defined and we were just talking about, and other. When we click on other, it brings up another graph. You can zoom in by pressing the plus button here at the bottom, and let's define a start symbol for this graph. So start, this is the entry point for the other graph. We're going to similarly define directional rules with E or east, and we'll say this is text from the second graph, other graph. But how do we get this text to run on another graph? How do we get the walker or the generator to move between graphs? So let's go back to the new grid graph. We've got the start symbol. It goes east to one of these three components. And let's go ahead and define a production rule. We'll say south this time. So a production rule directing for any of these three components, if they're chosen, to go to the other graph, or to go south to this cell. Now when we get to this cell, the syntax for moving between graphs is capital G followed by parentheses and the name of the other graph. So here, G parentheses other. Now what's that going to do? We'll start at this when we press the run button. Let's see. Component 1, and then this is text from the second other graph. So we started at the start symbol. We moved right, or x plus 1. The walker chose randomly among the three components and chose component 1. Based on the probability factors that were equal, it chose randomly component 1. Component 1, it had a directional rule saying that the walker could move south, or y minus 1. It moved to the cell below it, and then a rule in that cell there was one component, and that component said that you could move to another graph, other. Move to the other graph, there was one start symbol, so it started at that start symbol. It moved x plus 1, and then it picked up the text. This is text from the second other graph. But what happens if you have directional rules after you call another graph? So what if you start, you choose a component, you go to the other graph, and then there's a directional rule saying this is additional text from the first graph. Let's see what happens. We press the run button. Component 1. This is text from the second other graph. This is additional text from the first graph. So when you call the G function here to go to another graph, the other graph, that graph is placed on top of a stack. The walker runs through all that it can run through in that graph until it runs out of production rules. Once it's done, it this graph is popped off of the stack, and you go back to the original graph. You then run any production rules that are associated with the component where that graph was run, and the production rule states that this walker can move east or x plus 1 from there. There I'll pick up additional text from the first graph. And we can do that multiple times, right? We could say right in the middle of this text, G other, we'll call that graph right in the middle of this text. What happens then? Let's click the Run button. Component 2. This is text from the other graph. This is text from the second other graph. Additional text from the first graph. So you have chose component 2, said this is text from the second other graph. You have this is, followed by this is text from the second other graph, and then additional text from the first graph. See that again. Component 3 runs once. This is, it runs again, and then additional text from the first graph. So that's how you call other graphs and you move between graphs. But what if you wanted to, in the other graph, run yet a third graph? So let's call it graph 3. Let's define a graph 3 by typing a new name for graph name and clicking the new button. It starts you out on that graph. You can zoom in. Let's give it a start symbol to give it an entry point for that graph. Give it directional rules and say this is text from graph 3. Okay, so what's happening here? Let's go back to the new grid, and we're going to run it. Component 2, this is text from the second other graph. This is, and then we have this is text from graph 3. This is text from the second other graph. This is text from graph 3. Additional text from the first graph. Woo, that's a little confusing. There's a lot of this is and text from whatever graph, but basically what happened, you start, you pick up a component, and you run the other graph, right? When we run the other graph, start, this is text from the second other graph, and then you'll get this is text from graph 3. So graph 3 is placed on top of the stack. So new grid places the other graph on top of the stack. Graph 3 is then placed on top of the stack from within the other graph. Graph 3 runs out of directional rules or production rules. It's popped off of the stack. You go back to the other graph. There's nothing left for it to generate on the other graph. There's no more directional rules. So that's popped off of the stack. You go back to the new grid. And then this is, and then you're going to run it again. Others placed back on the stack. This is text from the second other graph is accumulated into the buffer. Graph 3 is placed back on the top of the stack. Runs that, gets the generated text there, pops it right back off of the stack, back to the other graph. Nothing left to do, so it pops back to the new grid. And then you get the additional text from the first graph. Let's run it again so you can see that in action. So you get selection of component 1. This is text from the second other graph, text from graph 3, popped off of the stack. This is, and then right in the middle of that sentence, you run the second graph again, other graph. That runs graph 3, which is put on the stack. They're both popped off, and then you get additional text from the first graph. In other words, you can deeply nest your graphs. You can run multiple graphs within a single graph. You can run those at however many levels deep you want to run. So you could have graphs that are 10 layers deep. And each time it's just going to be placed on and then popped off of the stack whenever it runs out of generational space on that graph.